Hello students, today we are going to discuss convolution sum. So what do you mean by convolution? So actually we have already discussed convolution, that means in a linear time invariant system. In a linear time invariant system, that is your LTI system, linear time invariant system, if your input is your x of n and output is your y of n, so how to get y of n? So y of n can be obtained by means of convolution. So y of n is nothing but what? That is your x of n convolution of h of n. What is x of n? X of n is your discrete signals and h of n is your impulse response of the LTI system. So output can be obtained through by means of convolution, x of n convolution h of n. What is its physical significance as far as your mathematical formula is concerned? So x of n convolution of h of n can be obtained using this formula, that is your k equal to minus infinite to infinite, that is your x of k into h of n minus k. So these are theory already I told you the previous classes. Already we have done on the number of problems related to convolution sum. So in a linear time invariant system, the output can be obtained by means of convolution, that is x of n and h of n. What are the basic procedures to find out the convolution? If there are two input signal x of n is given and x of n is a discrete signals and h of n is your impulse response of the system, the y of n we have to find out. So there are certain procedures. So there are some procedures we have to follow. First procedure is what? Already I told you in the previous class. First procedure is what? If x of n is given, then find out the x of k. Simply n can be replaced by k, and then h of n is given. So that is your impulse response. H of n can be nothing but your what? H of k. Then x of k is fixed. Then h of k, first step is to fold h of k by means of folding property. Folding means what? Folding. In folding property, whatever the h of k, simply k at every successive value of k equal to 0, 1, 2, 3, except 0, k whatever k equal to 1 can be goes to -1. Whatever k equal to -1 goes to k equal to 1. Whatever k equal to 2, 3 can be replaced with -1, -2, -3 like this. So this is all about your folding. Simply whatever value of k equal to 0, that will be fixed. Whatever the samples at k equal to 0, that will be fixed. Then k equal to 0, 1, 2, 3 can be replaced with -1, -2, -3, and k equal to -1, -2, -3 can be replaced with k equal to 1, 2, 3. This is all about your folding property. This is your step 1. Then after folding, then shifting. Then what is shifting property? So in shifting means what? The particular value of k. Suppose if I will shift after folding k equal to 1, 2, 3 like this. So this is folding. You have to find out that is your h of minus k. After h of minus k, then shifting. Shifting means what? H of minus k for minus k plus 1, plus 2, plus 3, and minus k minus 1, minus 2, minus 3 for every successive samples. After shifting, then multiplying. Then multiplying is your third step, that is your multiplying for particular value of n. For particular value of n, then multiplying. This is your first step is your folding, second step is your shifting, third step is your multiplying. After multiplying, then you will find out the particular value of n. So for successive value of n, we have to find out. Then at last we will get the convolution y of n by we will get y of n by means of convolution, that is your x of n convolution of h of n. All these parts already I told you in your previous classes. Now today we will discuss another one on examples, so that if you will do more and more number of problems related to convolution, your concept will be clear. Today this is the one of the examples related to convolution sum. So question is given here, that is your find the convolution of the signals x of n equal to 1 for n equal to -2, 0, 1, and x of n equal to 2 for n equal to -1 and equal to 0 elsewhere, and x of n is given and h of n is given. Already I told you previously how to find out the convolution. A discrete signal x of n is given and h of n is given. How to find out y of n by means of convolution? So x of n here given and h of n is given. So in this case, first of all, we have to find out there is a procedure. Already I told you in a previous class. In previous class already we have solved one or more examples related to convolution. This one today this example is slightly different than the previous one. Suppose we will do more and more number of problems related to convolution so that your concept will be clear. So x of n given here, h of n is given here. X of n is a functional representation of a discrete signals, and here this is a functional representation of x of n. Look at this here, x of n equal to 1 for n equal to -2, 0, 1. Here this is an x of n. Here this arrow mark indicates for n equal to 0. So that's why for n equal to 0 that is 1, n equal to 0 that is value is 1. Then n equal to 1. After arrow mark that is your n equal to 1, 2, 3. Before arrow mark like towards the left that is your -1, -2, -3, just like your number line. So n equal to 0 that is 1, n equal to 0 this is your 1, n equal to -1 also 1, n equal to 1 here that is 1, n equal to -2, 0, -1, -2 that is also 1. The three samples exist for n equal to -2, 0, 1. This is your -2, 1, that this is your 0, 1 and this is your 1, 1. Then n equal to -1 that is 2, n equal to -1, this is your n equal to -1, this is 2. So there is your 4 sample exist at successive values of n, and then this is your x of n, this is sequential representation, then h of n here, and h of n is what here? H of n equal to del of n minus del of n minus 1 plus del of n minus 2 minus del of n minus 3. So every discrete sequence can be expressed by means of delayed and scaled impulses. So here the impulse sequence can be represented in terms of impulses. So directly not written h of n equal to this like in your x of n. Here h of n can be represented in terms of delayed and scaled impulses. That is the slightly different than your previous example. Here x of n given the functional representation, but h of n not seen in the directly, and it can be represented by means of impulses, by means of scaled and delayed impulses. Here del of n means what? For n equal to 0. Already we know that in impulse signals for n equal to 0 this signal will exist, otherwise at every value of n it will be 0. So that's for del of n means what? For n equal to 0 the coefficient is 1 here. For del of n equal to 0 the this sequence exists here. If you look at this h of n for n equal to 0, this arrow mark here, the arrow mark is not mentioned here. That's why you have to sure that very first samples for n equal to 0. For n equal to 0 here the value is 1. Then n minus 1. Del of n minus 1 means what? Del of n minus 1 means n minus 1 equal to 0. For n equal to 1 this impulse exists, and the coefficient is negative, that means minus 1. For n equal to 1, if this is your n equal to 0, next immediately the next value, next sample is nothing but what? This value is nothing but what? N equal to 1. For n equal to 1, this minus 1, coefficient is minus 1, that indicates that for n equal to 1 impulse exists and the value will be minus 1. This is your minus 1. Similarly for del of n minus 2, what does it mean? Del of n minus 2 is nothing but what? For n minus 2 equal to 0, n equal to 2. For n equal to 2, the impulse exists, the sample exists, and coefficient is 1. For n equal to 2, n equal to here, the n equal to 2, the exists, the value is 1 here. Then del of n minus 3. Del of n minus 3, that is n minus 3 equal to 0. At n equal to 3, the sample exists and the value is what? Minus 1. The value here, the n equal to 3, the value is minus 1. First of all, you clearly know that in sequence representation of x of n and h of n, then we will proceed in our as usual procedure, folding, shifting, multiplying, etc. Then first in solution step 1, what we will do, that is your what? First, when we are going to find out the convolution of x of n and h of n, first of all you have to see what is your starting point of x of n and what is the starting point of h of n. Starting point of x of n. Starting point of x of n means what? That is your x of n starting here. Here arrow mark indicate n equal to 0. Here n equal to minus 1. Left side for n equal to minus 1. This is n equal to minus 2. the starting point of x of n, there is a formula, that is your xn plus hn. That is your what? Starting point of x of n plus starting point of h of n. Starting point of x of n is your 0, -1, -2. That's why this is your -2. Plus starting point of h of n, very immediate samples for n equal to 0 here. That is your starting point of h of n, that is your 0. So that is your what? That is your -2. So starting point of x of n, that is your -2. Similarly, starting that is your what? Then right extremum point, right here, not starting point of x of n, the start our sequence is what? Y of n. So starting point of y of n, not starting point of x of n, here the starting point here y of n. Y of n means we are going to find out or evaluate the y of n. That's why what the sequence here y of n we are going to determine. So that's a starting point of y of n. X of n, h of n is given. We have to find out the y of n, and the y of n whose starting point must be equal to starting point of x of n and starting point of h of n. So starting point of x of n is your -2, here -2, and starting point of h of n, that is your 0. That's why -2 plus 0, that is your -2. Similarly, the right extreme point, right extreme of y of n. What is right extreme? The length. Our motto or our aim is to find out y of n. The y of n must be what? What is the starting point of y of n? What is the ending point of y of n? Starting point of y of n must be -2, n equal to -2, and ending point of y of n, or right extreme point of y of n, equal to what? The ending point of x of n is what? 1. Here ending point, that is 0, 1, 2, 3. That's why 1 plus 3. That is your xr, formula is your xr plus hr. That's why this is equal to ending point of x of n, that is your 0, 1, plus ending point of h of n, that is your 3. That is your 3. That is your what? That is your 4. 3 plus 1, 4. Therefore, n equal to, that is your -2 to 4. N equal to -2 to. It is very important. First of all, we have to find out the y of n. Then we have to decide where I will start my convolution y of n, that is x of n, convolution h of n. That's why my starting point of n must be equal to -2 for y of n, and ending point of y of n, that is your n equal to 4. That is your length is what? -2, -1, 0, 1, 2, 3, 4. How many? That is 7. So that's why, or you may say that the x of n, length of x of n is what? 1, 2, 3, 4. Blindly, how many number of samples? First of all, you calculate. That is your what? X of n 1, 2, 3, 4. And h of n length is what? 1, 2, 3, 4. 4 plus 4, 8. -1, that is your 7. -2 to 4 is your nothing but 7. 7 samples of y of n we have to determine. So the length of y of n, or you may write down a length of y of n equal to, that is your L plus m minus 1. What is L? Length of x of n. Length of x of n, that is your L equal to length of x of n. M, the length of h of n. Length of x of n 4. That is your length of h of n, that is 4. And that is your -1. It is nothing but 7. So 7 number of samples we have to determine. Our required y of n length must be equal to 7 number of samples, and it will must be starts from n equal to -2 and end n equal to 4. Are you clear or not? So that's why it is all about your step 1 is your what? You have to determine what is the starting point of y of n. Then what you have to find out the ending point of y of n, and the length of y of n, that is your 7. Then here, first of all, x of, already I told you, x of k, whatever x of n, same as x of k. Then h of k, whatever h of n, that is your h of k. Next, that is your folding. From this we will start our sequence. H of minus k. Already I told you, for k equal to 1 to 3, it becomes to what? Comes to n equal to k equal to -1, -2, -3, like this. Whatever k equal to -1, -2, -3, then comes to 1 to 3. Since -1, -2, -3, no samples are there, that's why whatever 1, 2, 3 comes to whatever 1, that goes to -1, whatever 2 goes to -2, whatever 3 goes to -3. Here h of minus k is h of k and h of minus k is like this. if you observe whatever n k equal to 0, that will be same. Whatever 1, this is minus 1, that goes to minus 1. Whatever 2, that is 1, goes to minus 2. Whatever 3 goes to minus 3, that is your minus 1. This is all about your h of minus k. For then for we will start what? Sequence for what? N equal to, that is your minus 2. N equal to minus 2. For n equal to minus 2, x of k is same. X of k is what? X of k is simply x of in sequence representation, that is your 1, 2, 1, 1. This is your x of k. Then h of minus k. What is h of minus k here? In sequence representation here, h of this is your h of minus k. If I let in sequence representation h of minus k, that is your in 0, for k equal to 0, this is 1, and then minus 1, then 1, then minus 1. Carefully you have to written like this, so that any slightly mistake, your answer is totally will be wrong. This is your h of minus k, this is your graphically, and this is your sequence representation. Then comes to here for n equal to minus 2. You have to shift h of minus k. First of all, then this is your folding. This is all about your folding. This is your folding. Then shifting. Shifting means what? That is your shifting for n equal to minus 2. That is your what? We have to find out h of minus k minus 2. It is very, very important. H of minus k minus 2. After folding, x of k is fixed. X of k is fixed. Then you have to shift h of minus k. From h of k, obtain h of minus k. After h of minus k, then shifting for n equal to minus 2, that is your h of minus k minus 2. If h of minus k minus 2, this is time reversal, proper time reversal or time advance for k equal to minus negative and k equal to positive. For h of minus k minus 2, in graphical representation, every sample sequence shifted to left by 2 units. And in sequence representation, arrow mark shifted right by 2 units. First you observe here, h of minus k minus 2, h of minus k minus 2 like this is 0. Whatever this shifted to left by 2 units, whatever 0, this come to 0, 1, 2, minus 2. This is your minus 1, this is your minus 2 like this. This is your h 0 minus 1, this is your minus 2. Then whatever minus 1 goes to minus 3. Then like this 0, then whatever minus 1 goes to minus 3. This is your minus 3. This is your minus 3. Then this is your minus 4. Then this is your minus 5 like this. This is all about your what? H of minus k. Clear or not? This is your h of minus k, and every sample sequence shifted to left by 2 units. Here whatever 0 then comes to here. These samples exist at h equal to k equal to minus 2, because this is your h of minus k minus 2. Whatever 0, this comes to here, this position, this one. Again this will goes to 2 position, minus 3. This goes to minus 4. This goes to minus 5. So every samples shifted to left by 2 steps here. If you observe in sequence representation, I can like this, h of minus k minus 2. First this is your 0, there is no sample exists at 0, no sample exists at minus 1, arrow mark indicate 0. This is your 0, because for k equal to minus 1, there is no samples here. Then minus 2, that is 1, 0, minus 1, minus 2, that is 1, minus 2, that is 1, then minus 1, then 1, then minus 1. Okay, this is all about is your h of minus k minus 2, h of minus k minus 2 here. Okay, so this is all about h of minus k minus 2, and this is your x of k. Then y of minus 2, y of minus 2 is how much? Y of minus 2, look at this here. For here k equal to 0, here k equal to 0, 1 into 0, that is your 0, plus k equal to minus 1, 2, 2 into 0, that is your 0 here, plus above the right sequence there is no samples here, that means 0, for 0, 0 into 1, 0, then 0 into 2, 0, then 1, 0, minus 1, minus 2, 0, minus 1, minus 2, 0, minus 1, minus 2, minus 2, 1 into 1, 1, that is 1, result will be 1. Okay, so therefore y of minus 2 equal to 1. Y of minus 2, that is 1. Okay, similarly for n equal to minus 2, then come to what? N equal to minus 1. N equal to minus 1. For n equal to minus 1, what happened here? For n equal to minus 1, for n equal to minus 1, original sequence h of minus k, then comes to each sample sequence shifted to the left by 1 samples, by 1 unit, h of minus k minus 2, here h of, this is your h of minus k minus 2, and h of minus k minus 1, h of minus k minus 1 like this is your 0, okay, this is your 0, then h of minus k minus 1, whatever this comes to minus 1 here, 1, then here minus 1, 1, then minus 1. Okay, so every sample sequence shifted to left by 1 unit up to obtain, this is nothing but what? K h of minus k minus 1. In sequence representation, h of n equal to minus 1, that is your h of minus k minus 1, it becomes what? H of minus k minus 1. In sequence representation, here the graphical representation, that is your 0, for k equal to 0, that is 0, no sample exists at n equal to 0, then 1, then minus 1, then 1, then minus 1. This is your h of minus k minus 1. Then multiplying, same thing, x of k is fixed, multiplying x of k into h of minus k minus 1. So to obtain n equal to minus 1, that is your y of minus 1. Y of minus 1 is how much here? For k 0, for a k equal to 0, for n equal to 0, 0, and this is your 1, 0 into 1, that is your 0, plus then minus 1, n equal to minus 1, n equal to minus 1, that is 1, 1 into 2, 2, plus n equal to minus 1, n equal to minus 2, minus 1, 0, minus 1, minus 2, minus 1, minus 2, minus 1 into 1, that is your minus 1. Okay, so that's why 2 minus 1, that is 1. Therefore y of minus 1 equal to 1. In this process, we will find out from minus 2, n equal to minus 2, minus 1, 0, 1, 2, 3, 4, up to 4. This is all about y of minus 2, and this is all about n equal to minus 1. Then come to n equal to what? 0. After minus 2, minus 1, then come to 0. N equal to 0. For n equal to 0. This is your x of k and this is your h of minus k. K equal to 0 means whatever this h of minus k, as it is x of k and h of minus k. So x of k, h of minus k, that is your what? Y of 0, y of 0, y of 0, n equal to 0, y of 0 can be obtained, which equal to k equal to minus infinite to infinite, x of k into h of minus k, 0, minus k plus 0, that is your same minus k. The value is how much here? X of k, h of k, simply multiply this, that is your what? You may write here for better understanding, x of k in sequence representation, x of k, that is your what? This is 1, this is 1, this is 2, this is 1, this is your x of k, and this is h of k, h of minus k. For h of minus k, this is your 1, this is your minus 1, 1, minus 1, this is your what? H of minus k. Simply multiply for corresponding value of k equal to 0, 1, 2, 3, minus 1, minus 2, minus 3. For 0, this is your 1 into 1, that is 1, plus minus 1, that is minus 1 into 2, that is your minus 2, plus 1, 0, minus 1, minus 2, that is 1, 1 into 1, 1, 0, minus 1, minus 2, minus 3, that is 1, minus 1, here minus 1, minus 2, minus 3, no sample exists, that's why 0. So whatever n equal to 3, and that will be 0, anything will be 0. So that's why you will get, that is your 1, minus 2, plus 1. So 1 plus 1, 2, 2 minus 2, 0, that will be 0. Therefore, y of 0 equal to 0. Y of 0 equal to 0. So we have already find out the sequence for n equal to minus 2, n equal to minus 1, then n equal to 0, then come to n equal to 1, or n equal to 1. For n equal to 1, tell me, n equal to 1 means we have to find out h of minus k plus 1. That is your time reversal. So that is your what? H of minus k plus. Minus k plus means what? In graphically, it is the sequence, each sample sequence shifted to right by 1 unit here. This is your h of minus k. If you have to find out h of minus k plus 1, whatever 0 comes to, this is your 0, come to 1, this is your 1. Whatever minus 1 comes to 0, that is your simply minus 1. Whatever minus 2, that is your, this is your minus 1, that is your what? 1. Minus 3, this is your minus 1, then minus 2, this is your what? Minus 1. This is your minus 2. Okay, this is nothing but what? H of minus k plus 1. H of minus k plus 1. Whatever k equal to 0 goes to right by 1 unit. Whatever 0 goes to k equal to 1. Whatever minus 1 goes to k equal to 0. Whatever minus 2 goes to minus 1. Whatever minus 3 goes to minus 2. This is your h of minus k plus 1. In sequence representation, you can write here, in sequence representation, that is your 0 minus 1 and 1, that is 1, and here 1, then minus 1. Okay, so 0, minus 1, minus 2, that is minus 1, minus 1, that is 1, 0, that is minus 1, 1, that is 1. This is your h of minus k plus 1. This is your h of minus k plus 1. Same thing, multiplying. For n equal to 1, we have to find out y of 1. Y of 1 equal what? K equal to minus infinite to infinite, x of k into h of minus k plus 1. The value simply multiply x of k into h of minus k plus 1. Look at this here, x of k like this. For this arrow mark indicate for k equal to 0. This is 1, 1 into minus 1, that is your minus 1, plus n equal to 1. This is your 1 and this is your 1. 1 into 1, 1, plus come to left side sequence, that is your minus 1, that is your 2. Here minus that is your 2, and this is 1. 2 into 1, that is your 2, plus this is your minus 1, minus 2. Minus 2, that is 1. Minus 1, minus 2, that is your minus 1. 1 into minus 1, that is your minus 1. The value will be how much here? That is your minus 1 plus 1, it will cancel out. 2 minus 1, that is 1. 2 minus 1, that is 1. So that's why, therefore, y of 1 equal to 1. Y of 1 equal to 1. Then come to n equal to 2. For n equal to 2. For n equal to 2, what do you observe here? In graphically, each sample sequence shifted to right by 1 unit for as far as h of minus k plus 1 is concerned. From h of minus k to h of minus k plus 1. Whatever h of minus k, each sample sequence shifted to right by 1 unit in graphically, but in sequence representation, the arrow mark shifted to left by 1 unit. This is your h of minus k, this arrow mark come to here like this. This is your h of minus k plus 1. So similarly, n equal to 2, that is your y of 2, we have to determine y of 2. And y of 2 equal to sigma k equal to minus infinite to infinite, x of k into what? H of minus k plus 2. H of minus k plus 2. First of all, x of k is already fixed. We have to find out h of minus k plus 2. So h of minus k plus 2, in sequence representation, the arrow mark shifted to left by 2 units here. This is your h of minus k plus 1. Then come to 1 here like this. That is your minus 1. and 1 is shifted like this, and that is your minus 1 and 1. This is your h of minus k plus 2. Look at this here. This is your h of minus k plus 1, and we have to find out h of minus k plus 2. Whatever plus 1 shifted, sequence shifted by this arrow mark shifted to left by 1 unit here like this. And if you in graphically, the each sample sequence shifted to right by 1 unit from h of minus k plus 1. So this is your h of minus k plus 2. Simply multiply this one, that is your this with this, that is your x of k with h of minus k plus 2 to obtain y of 2. The value will be how much here? Successive value of x of k for this arrow mark for n equal to 1, that 0, that is your 1, and this is your 1. 1 into 1, that is your 1, plus n equal to plus 1, that is your minus 1, n equal to plus 1, 1. 1 into minus 1, that is minus 1, plus n equal to 1, n equal to 2, n equal to 2, there is no sample sequence, that will be 0. So 0 into 1, that will be 0. Come to left part of the arrow mark, that is your here n equal to minus 1, that is your minus 1, n equal to minus 1, that is your 2. 2 into minus 1, that is your minus 2. 2 into minus 1, this is your minus 1, and your 2. 2 into minus 1, that is your minus 2. And minus 1, minus 2, that will be 0. Minus 2, that is your 1. 1 into 0, 0. So that means we will not write down this one. So we will get 3 values for n equal to 0, 1, and minus 1. So that value will be how much here? That is your 1, that is your minus 1, minus 2. So that will be 1, 1 cancel out. That will be value will be what? Minus 2. Therefore, y of 2 equal to minus 2. Y of 2 equal to minus 2. Then we have to find out for n equal to 3. 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 For n equal to 3, we have to find out y of 3. Y of 3 equal to how much? Sigma k equal to minus infinite to infinite x of k into h of minus k plus 3. Okay, h of minus k plus 3. As already x of k is same, but we have to find out h of minus k plus 3. H of minus k plus 2, already we have to return h of minus k plus 2. Then h of minus k plus 3. In h of minus k plus 3, what happened here? In graphically, sequence shifted to right by 2 units. If h of minus k plus 2 is there, 2 units, but in sequential representation, arrow mark shifted to left. But here h of minus k plus 2 like this, from h of minus k plus 2 to I can get h of minus k plus 3, arrow mark shifted to the left by 1 unit. Minus 2, h of minus k plus 2 to h of minus k plus 3, arrow mark shifted to the left by 1 unit. That's why this is arrow mark is here. That is your 1, minus 1, 1 here. This is all about your h of minus k plus 3. Again multiplying h of minus k plus 3 2 with x of k. So the value will be how much here? Look at this here. This is your for n equal to k equal to 0, minus 1, and this is your 1. 1 into minus 1, that is your minus 1. 1 into minus 1, that is your minus 1. Plus. Then n equal to 1, that is 1. 1 into, this is 1 and this is 1. 1 into 1, 1, that is 1. Then n equal to 2 minus 1, there is no samples exist for n equal to 2. That's why 0. So 0 into anything 0. So right side sequence is always 0. In left side of n equal to 0, minus 1, minus 2, minus 3, no sample exists here. That's why whatever this value, this with multiplying with 0, that will be 0. You will get 2 samples, minus 1 plus 1, if you multiplying x of k into h of minus k plus 3. The value how much here? Minus 1 plus 1 will be cancel out. That will be 0. Therefore, y of 3 equal to, that is your y of 3 equal to 0. Then last part is your n equal to 4. N equal to 4. For n equal to 2, 3. For n equal to 4. For n equal to 4. For n equal to 4. For n equal to 4, we have to find out what? Y of 4. Y of 4 is how much? Y of 4 equal to x of k into h of minus k plus 4. X of k equal into h of minus k plus 4. H of minus k plus 3 is given here. Already we have derived h of minus k plus 3. Then from h of minus k plus 3 to find out h of minus k plus 4. So minus plus 3 to plus 4 means 1 samples. In graphically, it is shifted to the right, but in sequence representation, the RMR shifted to the left by 1 units. So that's why whatever this goes to left sequence by 1 unit, that is your what? This is your 0, this is your -1, 1, -1, 1. This is all about your h of minus k plus 4. So RMR shifted to the left by 1 unit. So that's why you multiply with h of minus k plus 4 with x of k here. For k equal to 0, 0, 0 into 1, 0 into 1, that will be 0. That will be 0. Plus n equal to 1 minus 1, that is your 1. 1 into -1, that is your -1. -1. And you will not get any values because n equal to 1, 1, n equal to 2, that will be 0. Nothing sample exists at n equal to 2, 3, 4. And whatever n 2, 3, 4 does not matter. And 0 into anything, that will be 0. That's why only this all value will be 0. The value will be what? That will be -1. Therefore, y of 4 equal to -1. In this way, we have derived all the values from n equal to -2 to n equal to 4. For n equal to -2 to 4, already we got n equal to -2, that is 1, and n equal to -1, that is 1, 1, 1, -2, -1, then 0, then 0, n equal to 0, that is 0, n equal to 1, 1, n equal to 2, -2, n equal to 3, that is your 0, n equal to 4, that will be what? That is -1. So, therefore, we have got y of n equal to, we have to find for n equal to -2, -3, from -2 to 4, that is your what? Y of -2, y of -1, y of 0, y of 1, then y of 2, then y of 3. For n equal to -2 to n equal to -2 to y of 3, then y of 4. L plus m minus 1. So length of y of n equal to length of x of n plus length of h of n minus 1, L plus m minus 1. The x of n length was 4, h of n length was 4, and 4 plus 4, 8, minus 1, 7. That's why length of y of n must be 7. -2 to 4. Whatever we have got, y of -2 is how much here? Y of -2, y of -2, that is your what? For n equal to -2, that is 1, -2, 1, -1, 1, 1, 1, 1, and this is 1. Then y of 0, y of 0, y of 0, 0, 0, 1, -2, 0, 0, 1, -2, 0, 0, 1, 0, 1, -2, 0, 0, 1, -2, 0, then y4 equal to -1, y4 equal to -1, then -1. This is our length of y of n by means of y of n, whatever y of n we will get, this is all about your x of n convolution of, this is nothing but your x of n convolution of h of n. We have to check whether our result is right or wrong. Here there is a procedure how to check your result is right or wrong, and x of n and h of n simply multiply. That is your, in x of n is how much? X of n value, x of n, that is your 1, 2, 1, 1. Blindly you can write down x of n 1, 2, 1, 1, and h of n 1, -1, 1, -1, 1, 2, 1, 1, 1, 2, 1, 1, 1, -1, 1, -1. This is your x of n and this is your h of n. Okay, x of n, h of n, earlier this is the two sequences given. So directly 1 second you will find out, though you know what will be the result, but procedure in this process you will find out to obtain y of n. After getting y of n, you have to check whether your answer is right or wrong. So x of n 1 to 1 1, h of n 1 minus 1 1 minus 1, irrespective of whatever the values of n equal to 0 like this. Simply you write down x of n and h of n and simply multiply this with this 1 into 1 1, 1 into 2 2, 1 into 1 1, 1 into 1 1. Similarly minus 1 into 1 1, minus 1 into 1 minus 1, minus 1 2 minus 2, minus 1 into 1 minus 1, minus into 1 into 1 minus 1. Then come to 1, 1, 2, 1, 1. Again minus whatever this, will you take minus sign, minus 1, minus 2, minus 1, minus 1. Okay. So then okay. So in this process, the y of n like this is your 1, then come to simply adding this minus 1 plus 2, minus 1 plus 2, that is 1, then 1 plus 1 2, 2 minus 2, that will be 0, then come to this one minus 1 minus 1 minus 2 minus 2 plus 2 0, that is 1, then come to here 1 minus 1 0, that is your minus 2, 1 minus 1 0, this is your minus 1. If you get, we have already the procedure we have followed by folding, multiplying, shifting, we have obtained y of n, and you will look at this and this result and this result will be your same. If it's slightly different, your entire calculation will be wrong and answer will get there 0 marks. These are long questions. You will get the questions from university examinations or any competitive examinations, and the convolution sum one question will be must from your university examination. So these are the procedure to solve how to find out the convolution of two discrete sequence x of n and h of n. If x of n is given and h of n is given, then what are the procedures you have to follow so that you will get the convolution sum of the response y of n of a linear time invariant system. Thank you. So coming classes we will derive more and more problems related to convolution sum. Thank you.